All right, class, welcome back to our unit on circles. And today we're going to start talking about angle measures and segments inside and outside of circles. Stuff is going to get really complicated based off of kind of what we talked about in the last couple videos with inscribed angles. If you haven't watched those, dude, stop now and go watch them. So we're going to talk about angle measures and segment lengths, what's going on inside and outside of circles. So we're going to talk about all about angle measures, arc measures, and segment lengths. And again, you know, I talk too much, so it'll be a couple videos. Let's begin, of course, with notes. So we get a couple interesting things that are happening. Look at this first note. What's going to go on when we have an angle formed by two lines that intersect inside the circle? Now, what you must understand in a case like this, that point of intersection may or may not be, chances are not, may not be the center. Okay, so first thing you got to understand, this is not necessarily the center, because if it was, holy cow, life would be a million times easier. So this is not necessarily the center. Because remember, if it was the center, then we have central angles, and as we all know, central angles are so kind and sweet and gentle. But outside of central angles, things get nutty. So off of the previous video, we discussed that when we're dealing with not central angles, the angle measure is half of the arc measure. That is going to maintain here. So if we have two lines that are intersecting inside the circle, the measure of either angle, so in this case, angle 1, right? So the measure of either angle is half of the sum. Whoa! Sum of the intersected arcs. Okay, so the angle measure is half of the sum of the arcs. Okay, that kind of makes sense if you're thinking about when angles move and all that. So it's half the sum of the two arcs that are formed by those two angles. So again, the angle is half the arc. That's a theme that's coming around. So we got to know when to add the two arc measures. So when the angles are formed inside the circle, not necessarily the center, you're not dealing with central angle, then we have to add angle is half the arc. Sometimes we have to subtract. What happens if the angle is outside of the circle and then the two rays intersect the circle, right? Making secants or tangents. Okay, so remember the vocab secants and tangents. So we have this situation here, and again, the angle is half the arc, but sometimes we got to know when to add and when to subtract. So if the angle is outside the circle, interesting stuff occurs. So the angle is outside the circle, we have to subtract our arcs. Okay, so we can subtract the larger arc from the smaller arc. And again, the angle is half the arc. Okay, so in another example, the angle is outside of the circle. We have a larger arc, and we're going to subtract the smaller arc. And again, the angle is outside of the circle. We subtract larger arc from the smaller arc. Okay, so we got to know angle is half the arc. Okay, that's when it's not a central angle. So that's basically it. Central angles equal, yay, everything's fun and fine. Not central angle, the angle is half the arc. We just got to know when to add and when to subtract. So let's do some practice with that. Okay, so here's a couple of examples going on here. We have a diagram, and the question is simple. Find the value of x. So what's going on here with this diagram? We have our angles happening inside the circle, and we know it's not the central angle. It can't be the central angle because these two arc measures are not the same. So as we know, the angle is half the arc, but we got to know when to add and when to subtract. In this case, we're going to add. Okay, so if we add our two arc measures, 46 and 90, well, that's a nice simple addition process. We have 136 total degrees of the arc, but we know that the angle is half the arc. Okay, so that's such an important note that I keep repeating over and over again. You'll never guess why. So the angle is half the arc. That means algebra can come and play now. Okay, so once we see that the angle is half the arc, or we can say the angle is half the arc, algebra can come out and play. So the angle is half the arc. See? Language. All important language. And so we can divide 136 by 2, and we'll come up with, hopefully that's 68 degrees. Yeah. All right, so the measure of the angle is 68 degrees. So that's how that note works. It's pretty straightforward. The angle is half the arc. So let's take another example. Now we have our angle on the outside of the circle, and stuff gets a little bit tricky. So here you go. Angle on the outside of the circle. We now have two arcs being formed, and the whole problem is we got to know when to add and when to subtract. So in this case, with the angle outside the circle, we're going to be subtracting our arcs. Okay, so the angle is outside the circle, we'll subtract our arcs. So here's the note. The angle is half the arc. Let's put algebra to the test. The angle is half the arc. And we know when to subtract. So that is the hard part right there. And by the way, in case you haven't realized, notice the difference between my 2's and my z's. I always put a line through my z's. Anyhow, so the angle is half the arc. All we've done is written down the algebraic version of what we've been saying. And we know when to subtract because the angle is on the outside of the circle. So, Mr. Katz, this looks scary. I don't know what to do. Oh my God, it's so scary. No, don't worry, guys. Simply clear the fraction. How does that work? How do we clear a fraction immediately without using the distributive property? So I know people are looking at that like, oh, distributive property, distribute the 1/2. I say, hold your horses. If half of this is 20, well then guess what? We can multiply both sides by 2, and we realize that this is actually equal to 40. Okay, so you can clear fractions quite easily. All right, so half of the right side is 20. That means the whole right side is 40. Right? So we can think, or we can use algebra. Either way, you can clear some fractions. So 40 would be equal to 95 minus z. I want you to algebraically look at what just happened because that's a really neat thing, which is one of the reasons why PEMDAS is a lie. PEMDAS is a lie. You heard it here first. So because PEMDAS would say multiply that. I say no. I don't want to. So what we can do is multiply both sides by 2. Anyhow, algebraically, we got a lot of neat things going on. Trust me, z is equal to 95 minus 40, but how do we get there? This is what we can do. We can subtract 95 from both sides, right? You can totally do that. If you do that, you're going to end up with 40 minus 95, which is negative 55. So negative 55 equals negative z. Well, that doesn't help at all. Then what does that mean for positive z? Well, positive z equals positive 55. So there's that way of looking at it. We could have subtracted 95. Now, in my head, just so you guys know, if you ever want to take the brave path and figure out what I'm thinking, in my head, what I do is add z to both sides, right? And then I have z plus 40 equals 95, and then I subtract 40. But that's just, and I do that super duper quickly because it's in my head. Either way, z is 55. So some neat algebra tricks. But that's not the point. The point is geometry. When do we add? When do we subtract? The angle is half the arc. A couple more examples. Here's another one. Here's another diagram. What is the value of w in this diagram? So once again, we have an angle on the outside of the circle, which means we're going to be subtracting. Okay, so we subtract our arcs, right? So the angle is half the arcs. The angle is half the arcs. But in this case, we are subtracting w minus 110. We subtract our arc lengths just like we have done in the notes. Subtracting our arc lengths, subtracting our arc lengths, subtracting our arc lengths. So everything is the same. So once again, algebra comes to play. I'm going to clear the fractions super quick, and I'm not going to show work this time. So 140 equals w minus 110. And then to solve for w, I simply add 110 on both sides. So w is equal to 250 degrees. That is our measure of w. Now, how can we super check our work? This is another neat thing. If w is 250, and this is 110, is all the way around 360? Yes. Yes. Check. Okay, good. Always make sure you know what you're doing. So there's those examples. Now what we're going to do is take these notes and make another out of this real world example. Get it? Out of this. All right, never mind. So we have a word problem. Yay. This is about a satellite in geostationary orbit. What does that mean? That means it's going to be the same position relative to the Earth. Above Earth's equator, and it has a viewing angle of Earth formed by the two tangents. God, I love that word. Tangents to the equator. The viewing angle is about 17.5 degrees. What's the measure of the arc of Earth that is viewed from the satellite? So the question is asking, what is the degree measure of this arc here? So we're going to call that x. Now, here's the problem. The problem is, well, I don't know what the other arc length is. Darn it. And again, algebra should start kicking in. Yes, you do know what that arc length is. Don't say you don't, because that's a false statement. You do. Mr. Katz, how? How? We know the whole way around is 360, right? Yeah. And this is x, right? Yeah. Well, then, segment addition postulate. This must be 360 minus x, right? Oh, I know. See, you know more than you think you know, because you got to be paying attention. Life is easier when you pay attention. So we have our two arc lengths. We have the angle on the outside. The note kicks in. We got to know when to add and when to subtract. In this case, we will be subtracting. And we also know that the angle is half the arc. Okay, so the angle is half the arc. But what are we going to do? Mr. Katz, what are you going to do? Just write it down, dude. We're subtracting. 360 minus x is the one angle, right? And then we're going to subtract x. Trust me, algebra is awesome. So once you write it down, everything is fine. If you don't know what to do from here, we got problems, but, well, pay attention. Maybe I can help you with them. So the first thing I'm going to do is clear the fraction. Like I said, I'm not going to show work. So if this side is half of this side, well, I'm just going to multiply everything by 2. So I get 35 would be equal to 360 minus x, right? Mr. Katz, I don't get it. Yes, you do. Because watch this. We can combine like terms. Minus x. You know how many minus x's that is? That's 2 of them. Minus 2x. Yeah. See? Algebra. And now we're all set. Okay, we could subtract 360 and divide by -2, or we can add 2x and subtract 35. It doesn't matter what. We're going to get the same result. So the hard part is done. So when we subtract there, we have negative 325 is equal to negative 2x. And then we divide both sides by -2. And you're thinking, but I don't want a decimal. Meh. Oh yeah, well, relax. You started with a decimal, so chill out. We might end up with a decimal. Big deal. So we find out that x is 162.5 degrees. Did that in my head. And you can check your work by doing the same thing we did previously. Make sure everything is adding up to 360 around. You can totally do that. And we're all set. And that's enough for now. There's more to this lesson, but we'll save it for the next video. Remember these notes. And remember again, the angle is half the arc. We're going to know when to add and when to subtract. Peace.